Let's explore decimals on a number line. In this diagram, we have the whole numbers 2 and 3 represented on this number line. And we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 spaces in between. So if there are 10 spaces in between 2 and 3, what does each line represent on this number line? They actually represent 1/10. So we can increase the value as we travel to the right on the number line by 1/10. So if this is 2 here, this is going to be 2 and 1/10. And that can be written as a decimal as 2.1. And then the next one will be 2 and 2/10, or 2.2 as a decimal. Then we would have 2.3, or 2 and 3/10, and then 2 and 4/10, 2 and 5/10, which is equivalent to 2.5, 2 and 6/10, 2 and 7/10, 2 and 8/10, and 2 and 9/10. This slide verifies that each line in between 2 and 3 represents 1/10, and 1/10 is being added to 2. So we get 2 and 1/10, or 2.1. Then we get 2 and 2/10, or 2.2. So each individual dash represents 1/10 of a unit. And 1/10 of that unit is being added onto 2. In this number line, what does each line in between the whole numbers of 32 and 33 represent? And then we're also going to label the number line with the values of each hash mark as we go. So between 32 and 33, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 spaces. And one whole number divided into 10 spaces represents 1/10. So it represents 1/10, or written as a decimal, 0.1. So therefore, if we increase by 1/10 each time, we would have for this second line 32 and 1/10. For the second line, we would have 32, for the second blank line, I should say, we would have 32 and 2/10. Then we would have 32 and 3/10, 32 and 4/10, 32 and 5/10, which is equal to 32.5, 32 and 6/10, 32 and 7/10, 32 and 8/10, and the last one would be 32 and 9/10. Here we can see the solution to this example, which is exactly the same as what we had on our number line. They increase by 1/10 each time for the hash mark, and the 1/10 is being added to 32. That gives us 32 and 1/10, 32 and 2/10, 32 and 3/10, and so on.